We are both extremely excited to have you all here today to talk to you about how you can leverage AWS Cloud Control API, which is a service that we announced last year, to automatically stay in sync with the latest AWS innovations all the time. So we're excited to be here. Before we get into the presentation, we would like to introduce ourselves. So I'm Rahul Sharma. I'm a product manager at AWS. Over to my colleague.
Thanks, Rahul. My name is Welly Xiao. I'm a principal partner solution architect here at AWS. Really excited to talk with you all about some of the other possible with Cloud Control API. Over back to you, Rahul.
Perfect. Thanks a lot, Welly. So let's get straight into it. In today's discussion, we will talk to you about the background and the genesis behind AWS Cloud Control API and the opportunity it helps address for all our customers and partners to stay up to date with the latest AWS innovations, like everything that's launched at this reInvent or the future reInvents going forward. We will then introduce you all to the benefits of Cloud Control API and obviously like give a product introduction, what that is. After that, we will do a demo to showcase the power of this product, followed by which we will talk to you about some testimonials and success stories by partners that have integrated with this product. And then we will talk to you about what's taken place over the last 1 year. Like what are the set of innovations that we have introduced so that like you are excited to integrate your solutions with this product. And then finally, we'll start with how you can really get started. So perfect, let's dive straight in. So before we share the background story behind what led to the birth of Cloud Control API, it's important to highlight the philosophy behind product development at Amazon in AWS. At Amazon, we work backwards from our customers. We follow this working backwards principle wherein we like hear what our customers and partners tell us, all the feedback. Then we work towards identifying the right solution so that you have the best experience. And then we ship and roll out the product. Cloud Control API was no different. It was very much the same. For us, it began with identifying who are our target customers. For us, we have 3 target customer personas in mind. First and foremost are developers who use AWS Partner Network solutions, tools to manage and monitor their cloud infrastructure. That's persona number 1. The second customer segment or customer persona are essentially AWS Partner Network partners who essentially build their software solutions on top of AWS and expose it to our shared customers. And these software can be infrastructure as code, configuration management, cloud security posture management, monitoring and observability, among others. And then the third customer segment that we are targeting are actually builders themselves who directly use the surface area of AWS's APIs to manage their cloud infrastructure. So these were essentially the 3 customer segments we were targeting. And we identified opportunity areas to address the core needs of each of these segments that we just identified. So I'll quickly walk you through what those opportunities were for what led to the creation of Cloud Control API. So the first opportunity was really on the target segment that we identified, that is developers who use partner solutions to manage and monitor their cloud infrastructure. What we have consistently heard from developers is that they want to leverage the latest and greatest AWS innovation to essentially build modern applications and have faster time to market, right? And we have heard from various developers here that sometimes there is a lag between when an APN partner solution can actually surface new AWS features and services. We have a lot of announcements this reInvent, right? And we have noticed that there have been lags at time. And developers don't want these lags. They want to like adopt and test the latest product so that they can ship it out for their end customers. Just to give you an example, there are many developers who prefer to use or prefer to configure an HTTPS endpoint as part of their Lambda function instead of like having to learn, configure, and manage a variety of services in addition to Lambda, right? And they use it for a variety of use cases. Essentially, if they want to implement webhook or a simple form validator as part of their individual Lambda function. Earlier this year, AWS Lambda announced the availability of Lambda function URLs. And developers expected to use these Lambda function URLs to essentially configure their HTTPS endpoint in the Lambda function so that they can get going immediately. They did not want to wait for their partner tools to implement its support because ultimately they want to boost their agility and productivity as they ship their products out. So for us, the real question was, can we support new AWS features and services on day one, right? Like so that developers can benefit from these new solutions. So that was opportunity number one that we identified. The second opportunity that we identified was specific to the AWS Partner Network Partner tools. And it's related to the first one, that is, we wanted to make sure that our partners can integrate with the latest AWS features and services on the day of launch, or typically on the day of launch with a one-time integration, right? And you may wonder, why was there even a need for this? As you can see on the screen, AWS continues to innovate rapidly on behalf of our customers. Today, we have over 200 fully featured services, many of them announced in leadership keynote sessions at this re:Invent. And just to give you the scale of innovation, just last year alone, we launched over 3,000 significant new features for our customers, right? Now, if you imagine as a partner, if you have to keep up constantly with these new features and services, it is time consuming. And what we have often heard from our partners is it can take few weeks and sometimes even months to have those capabilities exposed to our end customers. And just to give you the scale of what has happened over time, just to give you a time series, as you rightfully see here, in 2011, just a decade ago, we launched about 80 significant new features. And last year, over 3,000. That's over 30x growth and innovation. And there's many more to come over time. And what we constantly hear from our partners, and many of them, including HashiCorp, Pulumi, Red Hat, have told us that they want to be in a position where they're always easily integrated with AWS features and services without any undifferentiated heavy lifting. So that's essentially the opportunity segment that we have. How can we help our partners stay in sync with the latest AWS innovations, typically on the day of launch? And finally, the third opportunity was for builders. The opportunity here was, can we standardize and introduce a consistent set of APIs or control plane APIs that builders can use to manage their cloud infrastructure? And you may wonder, why is there even a need for that, right? Well, first of all, today, as noted in my earlier slide as well, there are 200 plus AWS services already in existence. And as applications get increasingly sophisticated, developers and builders that we hear are using a plethora of AWS services in combination with ISV SaaS solutions, right? And each of these solutions have unique and distinct service-specific APIs, like unique naming convention, unique input parameters, response elements, among others. And developer and builders who actually want a set of consistent APIs want to really minimize having to author and maintain custom code to really manage their cloud infrastructure, be it for tracking inventory or essentially like fetching resource configurations. They want an easy way to manage their AWS features. So these are essentially the three opportunities that really lay in front of us. And a question that we really had was, how can we introduce a consistent API method to interact with hundreds of AWS services, and in fact, beyond AWS services as well? And just to, again, illustrate, right, like what the complexity really is, if you look in the left-hand side of the screen, you notice we've listed down 3 services: Amazon EC2, AWS Lambda, and Amazon ECS. For each of these operations, you note like a different naming convention for APIs, right? Different input elements or input parameters. And at the same time, once you run these commands on CLI, you would get a different set of response elements, right? So this is at an operation level across services. If you were to think about one single workflow, like for example, if you were to create a fully formed Kinesis stream, as you see on the right-hand side, you would have to use a string, you have to string together multiple APIs to fully form a Kinesis stream. You have to provide the name of the Kinesis stream that you're creating, the shard counts associated with it, a separate API for adding tags to those kinesis stream, and also adding or defining retention period. You would need separate APIs. So the question here was, can we not just make it introduce a consistent API layer across hundreds of services, but also collapse and condense multiple workflow operations into most fundamental elements? And that's what led really to the birth of Cloud Control API. So before I actually hand over the mic to my colleague Veli to talk to you about Cloud Control API, just a quick summary of what the opportunities lay in front of us. The first was providing day one or close to day one coverage or support for latest AWS features and services for our developers. The second was primarily focused on allowing partners to leverage the latest AWS capabilities through a one-time integration by minimizing or removing complete heavy lifting, undifferentiated heavy lifting altogether. And the final was introducing a consistent set of APIs for our builders. So with that, I would pass on to Veli to walk you through Cloud Control API.
Thanks, Rahul. So I guess the questions now spark about what is Cloud Control API? What does this actually do? And how is this different, for example, from EC2 or Lambda API, for example? Cloud Control API essentially is a common set of API that is designed for developers to make it easier for them to be able to manage resources, cloud resources, consistently. It's also help them to leverage any new AWS feature, new services, effectively on the day of launch, or maybe shortly afterwards. And it does that by introducing a set of common API to manage end-to-end lifecycle of the AWS resources. So by using a single get command, for example, I can look up all of my Lambda resources or my kinesis stream, for example. And then using a single create command, I can create the same resources as well. So you might wonder how this actual standard API works. So let's take a look. So you have Cloud Control API. It introduced 5 sets of resource-oriented APIs. So there's a create resource, get resource, update resource, delete resource, and list resources as well. So we're going to call this the CRUDL APIs. And this resource-oriented API works against hundreds of AWS resources and also third-party resources that's available. When we say resource, it includes a set of common attributes and also handlers that handles the interactions with the underlying API itself. And these resources also have a consistent schema, like a consistent error response, and also standardized parameters. Now, you might kind of start to wonder, how this actually going to benefit for you as a customers and also as a partners. Coming back to the problem statement that Rahul mentioned earlier, first is about how we get faster access to new AWS services. And this is made possible by the availability of the CloudFormation registry, where all of the AWS services in terms of the resources and also resource built by third-party provider will be available. So for a new AWS services and feature, this typically will be available on the day of launch or shortly afterwards. And then the second opportunity is about having this unified interface to allow you to have one-time integrations to expose for a new AWS set of features. It means you do one-time integration with Cloud Control API, and then you get benefit by exposing to the future features and services. And why this is really important? Because with one-time integrations, you can save hundreds of hours of annual recurring development efforts by doing one-time setup and then expose yourself to the future services and launches as well. And lastly, this consistent CRUDL API really designed to make it easy for you to manage cloud resources and infrastructures in a consistent manner. And we're going to show this later on to you as part of the demo. But before that, let me kind of help you kind of visualize how Cloud Control API actually works with the underlying resources and services such as maybe EC2. So let's take a look. First, at the bottom layers, you have all of the services that are available in the Cloud Control API today. That's including hundreds of AWS resources and also third-party resources. And these resources are available in the CloudFormation public registry. And Cloud Control API externalizes these resources to allow you to integrate with it. Now, for example, infrastructure as code tools such as HashiCorp Terraform, Pulumi, and also Red Hat Ansible are integrated with Cloud Control API. You can also use Cloud Control API through the CDK and CLI. And you can also use it as part of the AWS toolkits, such as Visual Studio Code, JetBrains, and etc. And then for a set of partners, it's also bring the opportunity for areas such as cloud security, posture management, configuration management, observability, for example, to have a single integration with Cloud Control API, and then benefit from that one-time integrations. All right, so now is the demo time. I'm going to show you like a couple of the sample command with Cloud Control API, and I'm going to use that using the CLI command. So let's get started. Right, hope my screen looks okay. Now I'm going to start with something simple, like by creating a new resources. So to do that, we'll start with something very small, such as creating a new log group. So I'm going to copy this command, put it in here. So to create a new resource, I just identify what's the type of the resource, which is, in this case, is a log group, and then my desired state. Desired state include the properties, such as the log group name, or in this case, the retention days. Now, to see if this resource is completed, I can run a command to get the status of that resource. So in this case, this is the command. And then I grab my request token in here. And I can see in here that the status of the resource is now completed. So that's a very simple one, just to create a resource. Let's explore more into like describing that particular resource itself. So to look for that resource, I'm using a very common verb, which is get resource. I specify the type of the resources, which is the log group, and then the identifier for that particular resource, which is, in this case, is the test log group. And in here, I get the response output, which is including the type of the resource description is in here, and also some identifier and properties. I want to pay attention on these resource descriptions, including this identifier and properties. And this is where the consistency is matter. And I'm going to show you that by another resource that I'm going to describe, which is a Lambda function. So let's do that. So to describe that Lambda function, I'm calling the same API call, which is get resource, specify the type, which is a Lambda function, and then the identifier for that Lambda function. And then notice in here, there's some recurring patterns. I get the consistent response, including the identifier and the properties for that particular resource. Now, this is maybe will be easier if I use, for example, a JSON to basically pull that resource. So let me do this. So I'm calling the same command again, but I'm just using JQ to kind of highlight the resource descriptions and the properties for that resources. And in here, I can see that this is the part for a log group. Now, if I do it again, for example, for that Lambda function, and pretty much I can really expect where that response output will be. This is where that consistency matters, right? Because now I know exactly for the future resources, whether that may be a new services or new feature, I know exactly where that response will be in the output of the API. Now, when we talk about resource discovery, for example, if you look for all EC2 instance, I call EC2 describe instance. Lambda function, I call a list functions. For the log groups, I call describe log groups. This service-specific API is really good if you need to have that full control over how you want to do filtering, for example, or like a pagination for that particular resource. So like how much response that you want to get at one time, and then a type of filters that you want to apply on that resource discovery. If I want to do this with the Cloud Control API, I'm going to use one single consistent command to do that. For example, for my log groups, I'm going to call list resource, and then I specify all of the, and then I get all of the log groups that's available on that particular account. And then if I want to do the same thing for a Lambda, let me run this command again. I'm calling the same list resource and then specify the type, which is a Lambda functions. And then I get list all of those Lambda function resources. All right, so this will allow me to have that predictable response where I know exactly if in future I have a new resource type, and I want to do discovery for that resource, I can just use the same API command and then just specify the type of resource, which will be something new in the future. Now let's look into another set of operations. For example, if you look at how you're going to create a new Kinesis stream, that typically includes like creating a new stream and then adding a tags to the Kinesis stream, and then later on set the retention period. This service-specific API is really good if you want to have that full control over the lifecycle of the resources. Now let's take a look into how you do that with the Cloud Control API. So if I want to do this with the Cloud Control API, I'm using the same create resource command. And then I just describe all of my desired state, including the name of the stream, retention periods, the number of the shard counts, the tags, and etc. And what Cloud Control API does is that it handles asynchronously all of the calls to the underlying service-specific API, in this case is Kinesis, and handle all of those ordering. So I just need to declare what is the resource looks like, and then let Cloud Control API handle the interactions with the underlying Kinesis stream. Now, these types of atomic calls also really interesting if you explore about running an update for the resources. Let's give an example. We created a log source earlier, like a log group resource. And then let's say I want to update that resource by changing the retention period. Now, I want to create a rule where I want to check if the retention period is actually 90 days. And if it's true, I want to replace it with the new retention period, which is 180 days. So then I can create this patch document, which describes all of the operations. In this case, the first one is to run a test, followed by the value of 90. So we'll double check to see if the log group actually have a retention period of 90 days, followed by replacing that particular attributes with a value 180 days. Now, doing this using a Cloud Control API, I can run a single command, which is the update resource. And then I'll let Cloud Control API, again, asynchronously handle the interactions with the underlying API itself. Well, it will do a check for that retention days, and then if it finds the value is 90, it will replace it with 180 days. All right, I'm almost at the end of my demo. Earlier, I mentioned about AWS resources and also third-party resources. Now, let me show you another operations where we're going to actually manage non-AWS resources. In this case, I'm going to use Cloud Control API to create a new repository in GitHub. And this is made possible because, again, Cloud Control API use the CloudFormation registry, which include third-party resources such as GitHub and other types of resources that are available in the registry. So in here, I do the same thing as described. The type, which is in this case, is not AWS resources, but instead a GitHub repository. And then I define the desired state, including like the organizations and the name of the repository. And then again, under the hood, Cloud Control API handle the interactions, interact with GitHub to create those repository. And we can take a look in here. If I go to my browser, go to my repository in here. This is my new organizations. If I refresh, and then here I can see that new repository that I just created earlier. So how this actually works? This just works because, again, Cloud Control API use the CloudFormation registry, and you can see in here, you as a customers and partners, you can create these new extensions, including like third-party resources, and then make it available and publish it in the CloudFormation registry. And then a customer can activate these resources and use it using the Cloud Control API. So with that, I think I'm done with my demo. Rahul, I'm going to hand it over to you to talk a little bit more about some of the customer story that we hear on the field.
Perfect. That was phenomenal, Veli. Just having to consistently manage the life cycle of several AWS resources, as you demonstrated in the demo, be it like Lambda functions, CloudWatch log group, Kinesis stream, to even non-AWS resource ecosystem that is like creating GitHub repo using a consistent set of APIs exposed by Cloud Control API. Like that was just phenomenal to watch. And I hope everyone's jumping out of your seat to like see what are the success stories of our partners and how are really customers using this product and how you can actually leverage this product going forward. So in the next section, we're going to talk about some of our partner testimonials. So we'll start with HashiCorp Terraform. So HashiCorp essentially provides a cloud automation software product that enables organizations to provision, run, manage applications across multiple environments. Specifically, Terraform is HashiCorp's infrastructure as code product, and they integrate with Cloud Control API to create the Terraform AWS Cloud Control provider last year in September of 2021. And this is what our partners are telling. Here we hear HashiCorp's leadership telling us that by integrating their toolchain with Cloud Control API, our shared customers are able to leverage the latest AWS features and services typically close to the day of launch. Many of them, including the recently announced AWS Lambda Snapstart, like new innovations, all of them are supported on Cloud Control API, and therefore any of our integrated partner solutions, in this case, Terraform. Similarly, Pulumi, also an AWS partner, essentially offers an infrastructure as code tool that allows developers to create, test, deploy, and manage cloud infrastructure using general purpose programming languages. Pulumi integrated with Cloud Control API to create the Pulumi AWS native provider last year in September 2021 at the time of Cloud Control API's launch. And this is what the CEO tells us, that with this integration, like Pulumi does not need to manually implement support for new AWS features and services each time they're launched. Therefore, directly passing on the benefit of allowing Pulumi's customers and our shared customers access to the latest AWS capabilities close to the day of launch. And then we have Red Hat Ansible. We have Red Hat Ansible integrate with AWS Cloud Control API earlier this year in May of 2022. And as you would know, the Ansible automation platform really enables customers to provision and configure cloud infrastructure and really help streamline and operationalize activities across different tool chains within AWS. So this is what the leadership at Red Hat Ansible has to tell us as well. With the Cloud Control API integration, what it really helps Ansible is to quickly develop content for the automation of new AWS services and implementation of new features. So as part of this integration, Ansible created the Red Hat Ansible AWS Cloud Control Collection, which went live earlier this year in May 2022. All of these integrations today are in public preview, and we have heard several examples of customers actually use these partner tools, specifically the Cloud Control API integrations, to really move fast with deploying modern applications and really moving forward with faster time to market for their applications. And we have heard this from customers across different industries, be it financial services, be it healthcare, among others. And as we have more and more integrations, you will see larger customer ecosystems start benefiting from all the benefits that Veli called out earlier in the presentation. So now all these partner testimonials are great to have, but we would love to have more partners. Hopefully, some of you in the audience have your logo up in our testimonials page and have your customers hear about the success stories that they will start charting out. So we wanted to take this time to highlight some of the use cases that extend beyond infrastructure as code, right? All the three partners we talked about were in the infrastructure as code domain. We'll talk to you about some of the use cases that extend even beyond this. So in Veli's demo, you would have seen the use of consistent list and read API calls. One of the benefits of consistency across hundreds of services of AWS and even third-party ecosystem is that you can easily track resource inventory by account. You can easily fetch configuration of multiple different services using a single get resource call or the read call of Cloud Control API. And it's not just about consistent inventory management or fetching resource configuration. You can then apply your own business logic to perform various new value-added capabilities for our shared customers, which is, for example, you can add metadata of resources to metric logs. You can immediately, say, identify each time there is a misconfiguration in the resource that violates best practices, security, or compliance configurations on behalf of your customers. And beyond that, there is the benefit of uniform state management, which is by taking these business logic and exposing that to your customers, you can actually provide remediation actions for your customers to either fix their configuration state so that they're back to compliant or secure state for customers, and many more. And some of these use cases that we have constantly heard from a variety of our partners as we speak span across use cases such as cloud security, posture management, configuration management, monitoring and observability, cost and resource optimization, and many more, along with infrastructure as code that we already talked to you about in this presentation. So, as we noted, AWS Cloud Control API has been around for slightly over an year as part of the AWS family of services. So we wanted to talk to you about, in today's discussion, what's new? What has evolved over the last 1 year and almost 3 months, 1 year and 3 months since this was launched. So we'll take you through a journey over the last 1 year and tell you what are the set of innovations we have focused on and what's really coming ahead. First and foremost, September 30th, 2021, we announced Cloud Control API, and along with us, we had HashiCorp Terraform Integrate to create the Terraform AWS Cloud Control Provider, along with Pulumi, we integrated to create the AWS Native Provider. Next. Over the course of months, at the time, in fact, before I go to April 2022, at the time when we launched AWS Cloud Control API, it was available in all regions in the standard partition and AWS GovCloud US regions. So we were still missing certain regions, and that's what we focused on. So in April 2022, we announced the availability of Cloud Control API in Amazon Web Services China regions. Next, immediately the month after, we had Red Hat Ansible integrate with AWS Cloud Control API to create the Ansible AWS Cloud Control Collection. And over time, as we initiated the launch of the product, we had customers in regulated industries who wanted to leverage the benefit of these consistent APIs through private VPC endpoints so that none of their traffic is exposed to public internet. So keeping those feedback in mind and our philosophy behind product development, which is always working backwards from customers, we recognize the need to support AWS private links so that we unlock these use cases for customers in regulated industries. And then this quarter, very exciting. So obviously, as I called out, AWS resources, several new AWS resources and counting have been supported on day one, including so many of them announced in this reInvent, including the likes of AWS Lambda Snapstart, already available. You can start using it using Cloud Control API. Next, third-party resources. So you saw in Veli's demo, we could create and manage the entire life cycle of a GitHub repository. But it's not where we just stop. This reInvent, we announced the support for or rather CloudFormation announced the support for 50 plus new third-party resources across 10 new providers, namely GitHub, GitLab, BigID, New Relic, Cloudflare, Snowflake, Okta, PagerDuty, Rollbar, Fastly, among others. And this number is only going to keep on growing. So like as of today, as we speak, Cloud Control API supports over 100 AWS, like over 100 third-party resources across more than 25 partner providers for us, including the 50 plus new resources that we supported this time around. And we have also rolled out new AWS region support. So we rolled out Cloud Control API's availability in the AWS Middle East UAE region, followed by all the 3 new regions that came up or went live in AWS, that is Europe, Zurich, Europe, Spain, as well as Asia Pacific, Hyderabad. All of these 3 regions were supported on day 1 by Cloud Control API. And our objective is, as and when new regions roll out, we want to be available as soon as possible for our customers to benefit from availability in the regions. So with this, Cloud Control API is now available in all regions in the standard partition, in AWS GovCloud US, as well as Amazon Web Services China regions as we speak. So this is a journey so far, but there's a lot more excitement coming in as we speak ahead. We already have like a very populated roadmap, and we would love to give you a little bit of glimpse. But even before that, just want to wrap up and tell you, when we launched Cloud Control API, we were supporting about 350 plus AWS resources last year. This year, as we speak, we have added over 200 plus new AWS resources on Cloud Control API, and today we support over 620 AWS resources and counting as we speak. So what's in store for future? Increased AWS resource coverage. Today, we acknowledge and we have heard from our customers that some of the key AWS service resources like EC2 Security Group, EC2 Instance, and some resources in S3 families and some other services are not supported. So we have heard this, and we have this in the highest priority to support some of these service resources that were launched way before Cloud Control API was available. So we are in the process of making some additional changes to the existing resource implementation in a way such that Cloud Control API can support and be consistent when operating on these resources, while at the same time, we want to ensure that customers who already have dependency on these AWS resources don't feel any difference whatsoever as we roll it or migrate it from the older implementation to the new implementation, which is where Cloud Control API is built on top of CloudFormation registry. The next is added support for third-party resources, by which we mean over time we are going to grow our partner ecosystem of independent software vendors and SaaS providers who we would be working with, and potentially also building with, to have their solutions exposed as resources so that they are available on Cloud Control API. At the same time, we are also working with a community of any of you here in the audience can actually build resources and make it available on CloudFormation's public registry, and therefore expose it to Cloud Control API by default as well. And then finally, we talked about the consistency in the API layer, right? And we are focusing on really doubling down on the developer experience even further by adding improvements that introduce even further standardization as developers, builders, and partners manage AWS resources, or essentially manage their cloud infrastructure on AWS. So that's essentially greater emphasis or even more standardization that we can get to. So that's essentially what's in store for future. We can't wait to get you started with Cloud Control API. So I'll pass it on to Veli to walk you through getting started experience.
Thank you, Rahul. Really, I think the key takeaway from today is that using a single common set of APIs, you can manage all of the AWS supported resources and also future resources, and then also third-party resources. So I think that's the very key takeaway on how you can continue to manage those resources in the consistent manner where you know exactly how that response looks like. So to dive a little bit deeper into those, this is a couple of resources that will be available for you. There's a getting started documentations. There is also a blog that talks about the Cloud Control API. We also have the user guides and API that showcase some of the API calls that I used earlier in the demo today. And this is a resource that's available for you to get started. I want to say again, thank you so much for coming today. I hope that this is useful for you all. On behalf of myself and Rahul, thank you so much for coming. Rahul, anything else to say?
No, I would say thank you so much for being with us here today so that we could share how you can benefit from leveraging the latest AWS innovations faster and minimize any kind of undifferentiated heavy lifting as we speak. So we are thankful for all of you present here, and thank you, Veli. So we would love to take any questions that you have now.
Thank you.
Thank you.